take a look at this problem. Cindy and John working together can mow the lawn in 10 hours. Working alone, John takes twice as long as Cindy. How long does it take Cindy to mow the lawn alone? This is a shared work problem. So it says Cindy and John. So the format of it is you do 1 over Cindy plus 1 over John is equal to 1 over together. So this is a general format. Well, it says Cindy and John working together can mow the lawn in 10 hours. So working together, they can do it in 10 hours. So that would be 1 over 10. Okay, working alone, John takes twice as long as Cindy. John is being put in reference to Cindy, so Cindy should be the x. So Cindy will be 1 over x. And John takes twice as long, so if this is x, this will be 2x. Think about it. If this was 10 hours, twice as long would be 2 times 10, or 20 hours. Now at this point, this is a rational equation. And let's review our steps for solving a rational equation. Step 1. Get rid of parentheses. Usually that's via the distributive property, but it doesn't have to be. You can FOIL in some cases. Step 2. Get rid of fractions. Multiply everything by the LCM of all the denominators. Step 3. Solve for x. And that's pretty vague, but at this point you'll either have a linear equation, and then you'll use your 4 steps to solve, or you'll have a quadratic equation, and you'll use the zero factor property. In theory, you could also use the quadratic formula, but I don't think I've ever seen a problem so hard that made you use the quadratic formula along with the rational equations. And then step 4 is to check your answers. Okay, so let's take a look at this. First step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Let's first start with 2 and 10. And even though it's pretty trivial, I'll come over here and show it. Find the LCM of 2 and 10. Because what's trivial to one person isn't necessarily trivial to every individual. They need to see this. To find our LCM of those two numbers, we first do the prime factorization of each one. Well, 2 is already prime, so we just write that as 2. And 10 is 2 times 5. Now we start with our first prime. Start with 2. We're looking for the greatest number of 2's on any single line. There's 1 here, there's 1 here, so our greatest number of 2's is 1. We don't count how many there are. We're looking for the greatest number of 2's on any single line. And what I'm talking about is to the right of the equals. Then I go to the 5, and I'm looking for the greatest number of 5's on any single line. None here, 1 here, so it would be 1, 5. So our LCM would be 10. Okay, let's look at the x's now. We're looking for the greatest number of x's in a single denominator. There's 1 here, there's 1 here, there's none here. So the greatest number of x's in a single denominator is 1. So our LCM for this problem is 10x. And we'll multiply it times the 1 over x. We'll multiply it by the 1 over 2x. And we'll multiply it by the 1 over 10. Well, those x's cancel. These x's cancel. 2 and 10 are both divisible by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. And these 10's cancel. 10 divided by 10 is 1. 10 divided by 10 is 1. When you get done with that step, you shouldn't have anything left in your denominators. So we've got 10 times 1, which is 10, plus 5 times 1, which is 5, equals 1 times 1 is 1, so it drops away, and we got x. So then 10 plus 5 is 15. And that tells us Cindy took 15 hours. Now John is twice as long, so John would be 30 hours. And those would be our answers. I'm not sure what they're actually asking for, but let's see. How long does it take Cindy to mow the lawn alone? Okay, they don't care about John. Just Cindy would be 15 hours.